Hello students, I am explaining chapter 2 Is Matter Around Us Pure for class 9 science, and in this video I am going to explain the topic concentration of solutions. So let's start with the topic. So this topic we are going to explain based on the observation from activity 2.2. What is activity 2.2? This already I have explained in my previous video and I have uploaded that video on my channel. You can go through my channel and watch those videos and then you can come to this video so that you will understand clearly. So observation from activity 2.2. In activity 2.2, group A solution looked lighter in color, while group B solution was darker. So here we have done the activity by taking copper sulfate crystals. So in group A, the copper sulfate amount was less, and in group B, copper sulfate amount was more. So let me write it here. Copper sulfate, here it was less, and here copper sulfate was more. So when they mix this copper sulfate in a water, group A got light in color solution and group B got darker in color solution. This happens because the amount of solute in solution affects how strong or concentrated it looks. So whenever you prepare any solution, the color may be sometimes light or it may be sometimes dark. So this everything is based on the amount of solute which you add. Now what is solute? Solute is nothing but it is the component of a solution which is present in lesser amount. So remember, to prepare solution, we require two components. One is called solute and one is called solvent. So always remember the substance which is present in less amount, that is called solute, and the substance which is present in more amount, that is called solvent. In detail I have explained in my previous video. You can watch my videos. So here the color of the solution, it should be light or dark. It is depend on amount of solute. This is the meaning of this sentence. So based on this we can divide the solutions. So we have dilute solution, concentrated solution or saturated solution. Now we'll study one by one. So what do you mean by dilute solution? First one, contains less solute compared to the amount of solvent. So it is a solution in which amount of solute is less compared to the amount of solvent. Means what? Solvent is high and solute is less. Such type of solution is called as dilute solution, and always because your solute is less, the color will be lighter. Remember this. Example is group A solution, because group A has used less copper sulfate. Whatever solutions group A, group B has prepared, they have used copper sulfate and water. So group A has used less copper sulfate, that's why they have got light color, and that's why the solution comes under dilute solution. Second one is concentrated solution. Contains more solute compared to the amount of solvent. So in case of this, solvent is less and solute is high. So it is exactly opposite of dilute solution. So here solvent is less, solute is high, and solute is responsible to give the color. That's why appears darker in color. And the example is what? Group B solution, because group B has used higher concentration or higher amount of copper sulfate. And that's why here we can give the example of group B solution. So whatever solution group B has prepared, we can say this is a concentrated solution. Now the next third type, saturated solution. Now this is something different, that is called saturated solution. Let's see what is this. Contains maximum amount of solute that can dissolve in the solvent at a particular temperature. So at a particular temperature in a given solvent, how much amount of maximum solute we can dissolve, and that is called as saturated solution. And remember the word at normal temperature. You should not change the temperature. At a particular temperature or at a room temperature, whatever amount of maximum solute you can mix into the given solvent, that solution is called as saturated solution. If more solute is added, it will not dissolve. So see here how it is prepared. We should take a beaker, take water, say some 50 ml of water, should not change the quantity, you should keep it fixed, 50 ml of water. I'll write it here, it is a water, and in this water I will go on adding copper sulfate. So first I will add 1 spoon of copper sulfate, take a stirrer and mix the solution at a normal temperature or at a particular temperature. You should not change the temperature. Now you can see copper sulfate crystal will get dissolved. Once they dissolve, again add 1 spoon of copper sulfate and use this stirrer and stir the solution. you can observe that again the copper sulfate which you have added second time, that will also get dissolved and the color will get more and more dark because you are increasing the solute. Again add one spatula or one spoon of copper sulfate and stir it with the help of stirrer. Copper sulfate will again dissolve and repeat this procedure. There will be one stage at which the copper sulfate which you are adding into this water will not get dissolved. It will remain as it is into this solution. After mixing, after stirring also it will not get dissolved. That stage is called as no more solute gets dissolved. Remember, and the such type of solution at this stage, this solution we can call as saturated solution. But remember, you should not change the temperature, you should not change the amount of water. At a given amount of water, that is solvent, and at a given particular temperature, whatever maximum amount of solute it can dissolve, that condition is called as saturated solution. I hope you understood this explanation. Then, based on these all, the important one note, dilute and concentrated are comparative terms. You can only say a solution is dilute or concentrated by comparing it with another solution. So remember, dilute and concentrated. Dilute means what? It will have less solute, more solvent, but you should compare it with somebody less than what? The other solution. So that's why it is called as comparative term. Even if you say concentrated, imagine if there is one beaker and there is one solution. If you are going to say this solution as a concentrated solution, then you have to tell in this solution solute is high than solvent. But compared to what? There should be one another solution with which you can compare. So if you compare these two beakers, you can say this beaker, I'll say A, it is concentrated, then the another beaker, I'll say B. And that's why, remember, dilute, concentrated, these terms are comparative terms. There is no any fixed number for this dilute and concentrated. These both are used as comparative terms. So this was the important note in this page. Now we will move with the next. Now we are going to see next activity, that is activity 2.3. So in this activity, the first step, take water in a two beaker. So we are going to take two beakers. Say this is beaker 1 and this is second beaker. That is another one. I'll write it here 1 and I'll write it here 2. So here measure about 50 ml of water and pour it into two separate beakers. So I'm going to take 50 ml of water. So I'll take 50 ml of water in beaker 1 and exactly 50 ml of water in beaker 2. Label them beaker 1 and beaker 2. Already I have labeled it is 1 and 2. Now the next step. Add solute to the beaker. So add solute to the beakers. In beaker 1, add salt slowly while stirring continuously. So in beaker 1, we are going to add salt and this you should add slowly with continuously stirring. So this is glass rod. You will put the salt and after adding the salt, continuously mix it. In beaker 2, add sugar or barium chloride slowly while stirring. So in beaker 2, you are going to add, either you can add sugar or you can add barium chloride, that is BaCl2. You have to add slowly with constant stirring. So here also there is a glass rod. Add little bit of barium chloride or sugar, stir it well. Stirring helps the solute dissolve faster. Remember, what is the role of this stirring or what is the role of this glass rod? When you mix, the water which is present at the bottom, it will come up and the water which is present at the top, it will go down. And that's why movement of water or the solvent will be continuous, which will help to dissolve the solute which you are adding. That's why stirring will be done. Step 3. Observe when solute stops dissolving. So as I have told you, continuously you have to add, continuously you have to stir. So if you repeat this procedure, adding salt and dissolving in both the beaker, there will be one stage at which the salt which you are adding in the beaker 1 and the sugar which you are adding in beaker 2 will not get dissolved. It will remain as it is at the bottom of this beakers. And this stage is called as saturated solution. So we have to reach that saturated solution. Till you see that there is a solute present in these beakers, you have to go on adding salt in beaker 1, sugar in beaker 2 and continuously stir. So see here, observe when solute stops dissolving. Means keep adding solute until no more dissolves. This is now saturated solution. Now imagine we have reached a stage called saturated solution. So in both the beakers we can see at the bottom salt and sugar respectively. The solution has dissolved as much solute as possible at that temperature. So this activity we have done at a particular temperature. We have not yet changed the temperature, and at that temperature we have reached a stage where no more solute is dissolved. Now the next, heat the solution. Now we have to heat these solution. Heat both the beakers gently to raise temperature by about 5 degrees Celsius. So what you have to do? Keep these both the beakers on the burner and heat it. And how much you have to heat? You have to increase the temperature of both the solution by 5 degrees Celsius. So only till the temperature increase to 5 degrees Celsius we have to heat. Try adding more solute. So what happens when you heat? When you heat these beakers, the salt which you have seen here, which is not dissolved, that will start dissolving even in the beaker 1, and in beaker 2, the sugar which you can see at the bottom, that also will start dissolving because you have increased the temperature. Now, what is the observation? More solute can dissolve after heating. So once it gets dissolved by heating, again you can add salt and check. Is it dissolving? In the second beaker, again you can add sugar and check. Is it dissolving? So it will get dissolved because of increasing the temperature. Because solubility usually increases with temperature. So the capacity of this water or the solvent to dissolve the solute increases as we increase the temperature. So remember, solubility affects temperature. What is solubility? The capacity of the solvent to dissolve solute is called as solubility. So before heating, we had reached the solubility, but once we started heating, the solubility also got changed, and still it started dissolving more solute. Means solubility get affected by temperature. This was the main aim of this activity which we wanted to explain you. So activity 2.3 says that solubility affects due to change in temperature, or I can say solubility changes by changing in temperature. I hope you understood the activity. Now I'll move with the next one. Now we are going to see some of the important points again. So see here, compare solubility of different solutes. Now in first beaker we took salt, in second beaker we took sugar. Both the solutes were different. Then is there any difference in the solubility? So that we will see it here. You will notice that salt and sugar or barium chloride dissolves in different amounts. Means in the first beaker when you took water, say it is 50 ml, I'll write it here, 50 ml water, that is beaker 1, and in beaker 2 also we took same, that is 50 ml water, 50 ml water, H2O means water, and this is beaker 2. And when you started adding salt in the first beaker, and when you started adding sugar or barium chloride in the beaker 2, and you started stirring it with the help of glass rod or stirrer. Here you maybe have observed that after adding some 10 spatula or 10 spoon, you maybe have reached a saturated stage. Means after adding 10 spoon, no more salt can be dissolved in beaker 1. But it may not be true in case of sugar and barium chloride. It may take some 7 spoons less than the salt, or it may take 15 spoons more than the salt. Why? Because salt is different, sugar is different. Because both the solutes are different, the amount of solute required to reach the saturated solution will also be different. This is the main important meaning of this sentence. So see here, you will notice that salt and sugar or barium chloride dissolved in different amounts. This shows different substances have different solubilities in the same amount of water at the same temperature. See here, both have 50 ml, 50 ml water. Both are doing at the same time for a particular temperature. Say the temperature is 25 degrees Celsius, but still salt is taking 10 spoons and sugar is taking 15 spoons to reach saturated. Means the solubility is also depend on the solute which you are using. Now, second point, understand saturated and unsaturated solutions. Saturated solution means what? Contains maximum solute that can dissolve at a given temperature. And unsaturated solution means contains less solute than the maximum that can dissolve. So, what is the meaning of saturated and unsaturated? Here, I told after adding 10 spoon, it reached a saturated level. Means after adding 10 spoon, no more salts can dissolve in this water. Because when you added 10 spoon, the salts remains at the bottom of the beaker, it will not get dissolved. Means the capacity of this 50 ml water is finished to dissolve the salt. This stage is called as saturated. But when you had added first spoon at the starting, that solution is called as unsaturated, means still it can dissolve. So starting, when you added 1 spoon, the solute was very less compared to the maximum, and that solution is called unsaturated. But when you add maximum solute which will not dissolve, that is called saturated solution. Very simple. Next one, effect of cooling a saturated solution. So once you reach a saturated stage, that you can see the salts at the bottom of the beaker which is not dissolving, at this level, now slowly you have to cool. Now see here, if saturated solution slowly cooled, some solute may come out as crystal because cold water dissolves less solute. So when you take this saturated solution and cool it, the temperature of this water goes down. Now imagine, now I told at this stage temperature is 25 degrees Celsius, and if you have cooled it, imagine to 15 degrees Celsius, because of less temperature of the water or because of the cold water, its solubility decreases. It will not dissolve more solute at less temperature, and that's why you can see the salts crystal will be appearing in this water. So you remember, at high temperature it dissolves more solute, at less temperature solvent or water will dissolve less solute. That's why you can see the crystals appearing in the solution. Next one is concentration of solution. Concentration tells us how much solute is present in a given solution. Concentration, the word concentration is nothing but it will explain us how much solute is present in a solution. So if you have two beakers and imagine here it is a dark color and here it is a light color. So what do you mean by this? Dark is concentrated. Concentrated. What do you mean by concentrated? Here the solute is more. Solute is more. And light color means it is dilute. Solute is less. So concentrated word is explaining us or telling us how much solute is present. So in dark solute is more. In light solute is less. Therefore, this concentration we can explain in different terms. Like for example, mass of a solute per volume of a solution, or volume of a solute per volume of solution. Now I will not explain in the detail because we are going to see this all in a different video. So just now remember, concentration can be written as mass of a solute per volume of a solution, volume of a solute per volume of a solution. So in these terms we can explain the concentrations. Now we'll see the next, that is conclusion. So based on this all, what we can conclude is different solute have different solubilities. Yes, it is correct, because we have seen here salt has different solubility, sugar has different solubility at same temperature and same volume. Second, heating increases solubility for most solids. Yes, it is correct. At 25 degrees Celsius, it has dissolved, say for example, 10 spoon of salt and 15 spoon of sugar. But when we started heating the solution, these all the salts got dissolved and still extra sugar and extra salt we added to dissolve. That's why heating increases solubility. Next one, saturated and unsaturated solutions help us understand how much solute is dissolved. Yes, saturated means it is the stage where no more solute can be dissolved, and unsaturated means it is the starting stage where we can dissolve extra solute. So we will get the idea how much solute has been dissolved. And the next last point, concentration measures strength of a solution. Based on the concentration, we can say that it is having more solute or the solution is having less solute. If it is having more solute, strength is high. If the solution is having less solute, strength will be less. So these are the conclusions which we can do based on this activity. Each and every point I have explained in detail in this video. So when you watch this video, you will understand everything, all concepts you will get clear from this, all the topics. Now we'll move next. So as I told, expressing concentration is very important. So now we will see a little bit in detail about the concentration. There are various ways of expressing concentration of a solution, but here we will learn only three methods. So see here, first is mass by mass percentage of a solution. If you want to tell the concentration of any particular solution, there are many methods, but for your syllabus you have three. First one is mass by mass percentage of a solution. The formula is mass of solute. So it is mass by mass. By means divide. So mass by mass, therefore mass of a solute divided by mass of a solution into 100. So solute and solution both should be in terms of mass, that is grams or kilograms, which is called as mass by mass percentage. Second one, mass by volume percentage of solution. So see here, mass by volume means mass divided by volume. At the numerator, there should be solute. So here, mass of solute should be in terms of mass, that is grams or kg. By volume means divided by, solution should be in volumes. So see here, always at denominator it should be solution, at numerator it should be solute. So solute we are using mass, and solutions we are using volume, that should be in liter, into 100 because it is a percentage. And last one is volume by volume percentage. So volume by volume means both numerator and denominator, that is both solute and solution, should be in terms of volume. That is, it is in liter or milliliter. Therefore, volume of solute divided by volume of solution into 100. So these are the three terms which we can use to express concentration. Now based on this, we are going to solve one numerical which is from your NCERT book. So the question is, let's read. This is example 2.2 which is from your NCERT book. The question is, a solution contains 40 gram of common salt in 320 gram of water. Calculate concentration in terms of mass by mass percentage of the solution. So mass by mass percentage means what? We are going to use this first formula. So what is all given? We have 40 gram of salt and 320 gram of water. Which is in less amount? Salt is in less amount, and therefore salt is the solute, and water is in higher amount, so therefore water is solvent. Always remember, in any solution, I'll write it here, in any solution we have two components, one is solute and one is solvent, and always solute will be less and solvent will be more, and therefore here salt is solute, water is solvent. So now start solving. I'll write here answer. So answer, first we will write what all given we have. So I'll write here mass of solute. First one, mass of solute. What is our solute? It is salt. So I'll write here salt. How much it is given? It is given 40 gram. So I'll write 40 gram. And it is given actually, so I'll forgot to write here given. So I'll write it here given. Now next what we have? Mass of solvent. So I'll write it here mass of solvent. What is our solvent? Here we have water. So I will write water and the value is 320 gram. And when we mix a solute and solvent, we will get a solution. And that's why now I'll write mass of solution is equals to, what is the formula for this? Mass of solute plus mass of solvent. So substitute the values. So what we have? Mass of solution is equals to, how much solute we have? 40 gram. And how much solvent we have? 320 gram. If you add these two numbers, we will get 360 gram. And now we will use our formula, that is mass by mass percentage. So I'll write it here. Therefore, mass by mass percentage of solution. So what is the formula we have? We have the formula, that is mass of solute divided by mass of solution into 100. So here I will substitute the values because the space is very less. So write down is equals to 40 divided by 360 into 100. And when we solve this, here what will happen? This 0 will get cancelled, this 0 will get cancelled, and 4 divided by 36. So it will be 4 ones are 4, 4 nines are 36, and it will be is equals to, that will be 100 divided by 9, and when you divide it you will get the answer. Let me write it on other side. Final answer I'll write it here. Here final answer will be 11.1%. So this you have to solve completely. You have to divide 100 divided by 9, solve it, and then write down the answer. And as I have told, it is mass by mass percentage. You have to write this percentage symbol for the answer. If I want to show this calculation, I can show it here. Let me show it here so that you will understand clearly. 100 divided by 9. So 9 ones are 9. Here minus 1 will remain. Here to be 0. Take again 0 at the bottom. Then 9 ones are again 9. So here 1 will remain. 1 carries 0. Now there is no number, so I should take here 0. Then decimal comes. Again 9 ones are 9. And this continues. Therefore, we can write our final answer as 11.1. So that's why the answer is 11.1, and percentage symbol is just because we are using the formula mass by mass percentage. So here I have completed the whole explanation of this topic, that is concentration of the solution. I hope you will understand this video. This video is very important. Everything clearly you will understand in this all, with this all the examples also which we have solved just now in this page. So if you like my videos, share my videos with your friends, and if you are getting little bit also benefit from these all the videos, then please consider subscribing my channel. Thank you so much.